Go and look at the thermostat controller for controlling energy. Generally used to control a heating element, and it does that by controlling these contacts here. These contacts are controlled by a bimetal, which is just sitting here, and we heat that up with a heating element, and as it gets hot, it pops open this snap action contact here, pulls that up. Quite often hear it in your heaters when it goes dink, and it opens up. It turns the heating element off, slowly cools down, comes back on, makes contact again, element comes back on, and produces heat. That then slowly warms up again, pops back open with the dink, and the process just keeps repeating and repeating. We can control the distance in here with this knob. That knob does is it drives a cam around, and cam which is a lopsided oval, and it shifts the distance between here and here, and that's going to just control how long on and off the cycles are. We'll just look at the circuit in a bit more detail. We've got our contact here, which is controlled by the heating element here, popping that switch open and close, open and close. 3 terminals, line. This is going to be our feed in, our load, where we put our load on. In this case here, there's a heating element here. When we do this in the practical in the workshops, we're going to be hooking a light here so we can see the load coming on and off. And our last terminal is the neutral. So the neutral is common to the load as well, because what it does is it sends a current through this heating strip, and this is in parallel with the load itself. So what happens is we get these thermostats, and they've got 3 terminals which we have to be able to identify these 3 terminals before we can hook up our load and our feed into the thermostat. So these thermostat terminals are just labeled A, B, and C, and we don't know how they relate to the line, the load, and the neutral. So we're going to have to run some tests on these to discover which terminals are which before we can hook it up. What we'll do first is use our meter over here. We'll make sure it's in ohms, sitting on the ohm scale, and we should be able to measure the resistance between all these contacts and the different settings. So what we'll do is we'll put in the off setting to start with and take some readings. So I'm just going to get a measurement reading between A and B in this case here, and we'll fill out this chart as we go. In this case here, we're going to get 0.L, which means open circuit on a multimeter. So we'll just record that in here. Now we go between A and C and have a look at our thermostat's still turned off. We're measuring the resistance between A and C, and we're getting 15 kilo ohms. So we'll just write that in here. Now we'll just do our last reading between B and C, and once again we get 0.L, which is open circuit, so we put that in there. Now we'll turn our switch on. It's sitting down here on 4 now. So it's now turned our switch on, and we'll do the same set of 3 readings with the switch on. So between A and B, measure the resistance there, and we get 15k. Fill that in our chart. Measure between A and C now, and take the reading, and the reading still stays at 15k, so we'll write that in our chart. The last pair to test between again is B and C. This is once again with the switch on, and our reading for that is 0.0 ohms. So if we've got 0 ohms, 0 ohms, and a switch is of course closed, so we'll put that in there, 0 ohm closed. And then we're going to look at this data here and work out our terminals from down here. We'll get rid of that equipment and just have a look at our data. The key is this BC here, B and C. When the thermostat's off, we've got to open, and when the thermostat's on, we've got to close. So B and C definitely has to be these 2 contacts here, the line and the load. line and the load. So we write that in, B and C, line and load, but we still don't know which one, whether B's a line or C's a line or B's a load or C's a load. But we can work that out by looking at the rest of this data here. A and C here has 15 kilo ohms no matter what state the thermostat's in. The thermostat's off or the thermostat's on. It's 15 kilo ohms here. The heating element on our biometal is always around 15 kilo ohms. So the two terminals that has always got 15 kilo ohms on it, no matter whether the switch is open or closed, is between the load and the neutral. So we can identify A and C as the load and the neutral. So if A and C are load and neutral, and B and C are line and load, the common one is load. Therefore, C has to be load. So now we've identified C as a load, we know that B is our line and A is our neutral. So we'll just write all that down. Okay, we've identified all our terminals. Let's put them on this circuit diagram there and then hook up our circuit. Alright, terminals labelled. We'll shift the circuit across and we'll look at hooking all the gear up and testing the circuit. Keep in mind that all these thermostats, the terminals are labelled A, B and C, but they've all been wired differently, so we've got to go through this process for every thermostat. Here's one of our power supply boxes, one of our thermostats and a lamp. So let's cook this. Let's hook all this equipment together using the information we've got down here. Our B goes to our phase, put that in there. Load is C, so we put our load here, the light bulb, into C. A is our neutral, so put a neutral into there. But that's all hooked this circuit up here, but this lamp still isn't going to go because it's got no neutral return, so we've got to hook a neutral into that. Finished circuit, ready to go.